Alright, so let's try to do something interesting with this graphical library. So you probably, yeah, I already demonstrated that we can do the terminal rendering, right? So let's actually take a look at that one more time. But the native version actually is colorful, right? So it has colors and shit. And the modern terminals are also capable of rendering colors. The question is, can't we interpolate this thing with the terminal colors? Know what I mean? That would be kind of cool if all of that was rendered in the terminal, but with colors. Let's give it a try. Why not? I think I even had it to do for that specifically, right? So if I take a look at VC demo, so ANSI, use ANSI terminal colors for color to char, and color to char is basically the function that accepts the pixel and returns your character. By the way, we need to update the title, right? Because we're currently scamming people by saying that I'm rewriting bash script in C because I already did that. So what we need to do is that 3D graphics in terminal, in text terminal. Does it sound epic? Does it sound something you would click on? Okay, I think it's good. I think it's good. So 3D graphics in text terminal. There we go. So, but I don't know how to do the ANSI colors because I'm not some sort of a zoomer who the first thing they do is add shit ton of colors to their output because it's fancy and cool. I don't really know how to do that, so this is something that I'll have to research first. So let me see. So ANSI terminal color codes. I don't know how to do that really. Okay, so we have that. I have no idea what is a 0, 1. So it's just, is that an escape code? Is that an escape code? Maybe. So let's give it a try. So let's call it color.c, right? stdio, and probably not gonna need anything else. Right, there we go. So you see, I just googled it up, right? People constantly ask me, like, Zozin, what is the best C book to read about C? Like, I never read a C book, I just Google shit. Right, so is there any book that tells you this kind of stuff? I don't think so. I'm not even sure if this shit correct. That's how cool it is, right? So the book is usually like reviewed by the editors and stuff like that, make sure that everything is correct. I just slap some query in the Google, it spit out some shit. I'm not even sure if it's correct. There we go. We done something, right? That's how I develop things. Who reads books in 2022? I don't know. Okay, so let's actually do hello seaman. Hello seaman. And let's try to build this entire thing. Clang o color color.c, and I'm gonna also instantly run this entire stuff, and as you can see it says hello seaman. Right, so hands up. Okay. Hello seaman, hands up. So let's actually try to make this entire thing red. I wonder if I can literally like copy paste this entire thing in here and hope that it, okay, universal character name refers to a control character, so I can't just do that. Alright, so let's actually go to this website. So as you can see, it's not particularly correct. So the ANSI color, the character is a special character that starts off most ASCII allow syntax for it's a 1B. Wait a second, I think I know what the fuck is this shit. Python 3, if I do 1B, it's an escape character. It's an escape character. Okay, why didn't you tell me that? Alright, so how can I do an escape character? Can I just, you know, 27. Yo, it worked! Can you learn this kind of shit in a book about C? I don't think so. That's a very creative way of doing this shit. So I wonder how can I okay, C printf escape code. I forgot how you do that in C. So escape code 27. ASCII character escape code left arrow. Is it left arrow? Okay. Is there just like a convenient way of doing that? I don't know. So this is Python, but I don't want Python. So how do you do that? Ooh, you can put E in here, can you? Yo, it works. Who needs books about C? You have Google, am I right? Alright, so that's actually pretty cool. Did it? Oh, so somebody created a gist. So rabadabadoba, rabadabadoba. Thank you so much for this gist. Yo, this is so cool. I'm gonna actually give the link to these things, like for everyone. Look at that. I'm gonna also give you the link in the description. Why do I have Cyrillic? Where's my description thingy? So I probably need to create another thing. So what's the title for today's stream? So today's date is 02/12/2022, the worst year so far. And since we have a trend of the next year being worse than the previous one, looking forward for 2023. Jesus Christ! All right, so color ANSI codes in C. There we go. So this is what we have. I wonder if we can have like RGB shit. That would be kind of cool, I think. So there's also bold text, regular text. Maybe I'm gonna go with the regular text, right? So I'm gonna copy paste this thing to color and C. So there is a little bit of a discussion. So okay, this is interesting. 16 colors. I think this is more important in here. So most terminals, apart from the basic set of 8 codes, also support bright and bold colors. These have their own set of codes. Okay, so 16 colors. 256 colors. Yeah, I kind of want to do this kind of shit. Lastly, after the 16 colors, some terminals support 256 colors, extended color set. Okay. So there is a range of those things. All right. So the background colors. All right, I think I'm interested in this specific example. And what it does, essentially, it sort of like iterates 16 by 16 table, right? It's a 16 by 16 table, and just puts the cell. Okay, that's very interesting. And for each row in here, it, I suppose, updates the thing. So let's try to like write this specific code, but try to write it in C and see how it goes. Because I'll need to come up with a way to transform the RGB to these sort of colors, right? So we'll see how we can do that. Okay, so this one is like this. So this is the first thing. For int j16 plus j. And then we create a new code, right? And this one is effectively 16 plus j, right? So this is the row and this is the column. And then we need to do printf. So we do E 48, then 5, and then here we have to put a code in decimal. So we'll have to do like %d, then m, and then space. And here they just put some some code. I'm not sure if it's like really necessary, so I think I'm gonna just keep it as a space. And here I just put a code. There we go. And then we print 0m. I'm not sure what is 0m though, like this specific thing. So it's a reset. Okay, so that makes sense as well. Print f e 0m. There we go. But on top of that, I feel like we also have to maybe put a new line just in case. I think that makes sense as well. Okay, so it did something, but the problem is that we are in Emacs, and Emacs is pretty shitty terminal. Right, so we won't be able to see anything particularly interesting or useful, though we have like 16 by 16 things in here, so that's fine. Okay, so if I try to run this into... There we go, now we're freaking talking. Now we're freaking talking. So we have like the basic colors in here, right, so which is nice. And then we have extended stuff, and it just like goes through different gradients and stuff like that. I wonder, so what is the name for these extended colors? Can I Google something up, like map RGB to 256 ANSI Terminal colors? Is there any... okay, that's actually pretty cool. 256 cheat sheet xterm hex. All right. Cool. You know what's interesting? We can take this shit and do reverse mapping. Essentially, we have the color code. We can iterate through all of the 256 and just see to which the colors RGB vector is the closest. And we can just use that specific code. So this is something that we can use. There's RGB support. Okay. ANSI Terminal Colors RGB. ANSI color specific RGB sequences. Chat says that RGB exists, but you can never trust the chat because chat, like, you know. Okay, both answers fail true. Okay, so there is a true color ANSI support. Okay, instead of 5, specify RGB. Okay, so we can give it a try then. And RGB is from 255. So you know what I'm gonna do, essentially, I think. I'm gonna try the following thing, so it's gonna be from R. And let's try actually like a limited space, right, to 5. Right, essentially what I'm gonna do, I'm gonna split 256 by 5, and I'm gonna do in 256 by 5 steps, right? So I'm not gonna generate like the entire, like a true space, true color space, right? Only like a limited one. So let's replace this stuff with that. Fog. Okay, and I'm gonna replace G with B. Okay. So let me see. So this is what they... Oh, you can also do X. Alright, so that's pretty cool. So this is going to print F, but I suppose we can just do E. So this is R, G, and B. So essentially we have 255. We divide it by 5 effectively, and we multiply it by R, right? But when we divide by 5, we lose a little bit of information, so we probably want to first multiply by R, and only then divide by 5. That way we lose less information, right? So it becomes a little bit more precise like this. Okay, so, and if we do something like 5 by 5 by 5, it's 125, right? So that's how many colors we have in here. But it would be kind of nice to maybe, you know, put a new line in here, right? So we put a new line in here, and then also put a new line in here, right? So it's basically split into these squares, separate squares, right? With different shades of red, if you know what I mean, Right, so we can try something like this. If this will work at all, obviously it probably won't work in the in Emacs. Right, so we can give it a try. So yeah, there's literally nothing in here, but maybe it will work in here. So let's give it a try. Something happened. Oh shit. Okay. We probably need to do a reset every time we sort of like put a new line in there, right? So we probably have to do some sort of a reset thing. All right, so this is going to be a reset. This is going to be another thing in here. Okay, and let's run the colors, and nothing happened. Okay, so maybe my terminal just simply doesn't support, or maybe I just like missed some of these things. So I need to double check if I copy pasted everything correctly. So let me see. I'm gonna copy paste this stuff one more time. So okay, maybe I need to put a space in here. Right, maybe I need to put a space in here. Okay, we're getting somewhere. We're getting somewhere. Okay, so true color. So there's a math around. So RGB to ANSI 256. And ANSI is just like this weird thing. So I didn't think I did everything incorrect. So C, check if terminal supports true color. Is there any way for me to check that? Check if terminal supports 24-bit true color. So so color term, or XVT XPM, right? Can I say color term? Can I set this entire thing to true color? Probably not. Yeah. T-put colors. So essentially, if we do T-put, we only support 8 of them. Yeah. So it's kind of interesting. Maybe I should try to use xterm, right? So xterm is kind of like small, you can't see anything in here, but maybe it is like it does support this kind of thing. No, it doesn't support that. So URXVT. So URXVT true color. Right, so this is the terminal I use. Maybe I have to have a special build of this thing. Really? So, oh my god. So can ST from Sackless support that? Sackless ST. Let me actually see. Maybe we can try to do that. How can I download? Okay, so I can download it in here. And then I'm gonna move ST to here, ST, and I'm gonna go in here, and so it's make. Does it have make? Yeah, it does have make. Okay, cool. All right, so ST, cool. And then if I try to do color, still is for that. Okay, so apparently we're not gonna have the true color, so we can't have that unless I have a special terminal, right? So what we're gonna do instead, we're going to use 256 colors, right? And we're gonna try to do that the way I describe it, right? So essentially we're gonna build this reverse table. All right, and we're gonna literally look it up inside of table, trying to find the closest thing. All right, so let me quickly copy paste this stuff. 256 colors. yes. Yep. Oh boy. Right, so this one is apparently 0. Right, this one is apparently 0, and I didn't copy paste it properly. No, I actually copy pasted, but okay, so it just needs this kind of thing. All right, so I wonder if I can refer to these kind of things as tables. So this stuff is separated with tabs. So this stuff is separated with tabs. I can maybe put a white space mode. Yeah, we can clearly see that all of that is separated with tabs, which means that I can probably parse it as CSV or I remember there was a tool, something like TR, translate or delete characters. No, I think it was something like cut. Yeah, remove sections from each line of file. So yeah, you can have fields, select only these fields. Right, and there is also delimiter instead of, yeah, so essentially we can literally just use cut to transform this entire file. Okay, so colors txt, right, colors txt. So let's give it a try. We're gonna do cut, and we're gonna provide the fields. I only care about the field 1, 1, 2, 3, 4, and 4. I wonder if it will just work like this. Colors txt. Okay, so I'm an idiot. Let me see. Fields. Select only these fields. Also print any line fields, and it's a list. Linux cut fields list. There we go. Command examples. So if you want cut only the second through, but what? Okay, so you can put a comment here. So man should actually put the format in here. Like, come on. Right. So there we go. Now we're freaking talking. This is what I needed in here. Okay, that's cool. We've got the table. And now I can just like copy paste it into my code. So this is gonna be color C. So let's just copy paste that stuff. So for the colors, I don't know. Do I need anything special? So I think I'm gonna create something like uint8 color table, and we're gonna have 256. You know, I think I need to actually only the fourth thing. Yeah, so let's actually take only the fourth thing, because the index is the position within the array, so we don't need anything else in here. Right, so this is going to be that, and then we're going to have 3 of those things, right, and then we're going to just wrap this entire stuff like that. There we go. Cool. So in here I can try to query replace RGB with basically nothing. So let's actually remove RGB, and also query replace this with that, right, and then query replace this with that. There we go. Now we have a table. Isn't that cool? Isn't that cool? I think it's pretty freaking cool. Okay, so let's do something like find ANSI index by RGB. So we're gonna provide uint8r, uint8tg, uint8tb. There we go, and it should return basically the integer, right? So we might as well even, well, I mean, we should always return something, right? So because we're looking for the closest one anyway. There we go. So might as well, you know what? Let's do the integers, right? So it does not necessarily has to be uint, right? It does not necessarily have to be uint. So, and let's just go ahead and iterate through the indices. All right, so it's going to be 0, 256. 256. Oh boy. So let's do the result. The result has to be, let's start with 0, right? And return the result. So what we want the distance from the current one and the one we're looking for, right? So effectively we want something like dr, and it's basically r minus color table result. Maybe let's call it index result 0. So then g1 b2, right? So this is the distance. We can actually calculate the square of the distance, right? So that way we don't really need any square root or anything like that, right? Because we're going to be comparing the distances. And we probably need to also keep track of the current distance, right? So what's the current distance? And the question is, how do we compute that? So maybe one of the things we have to do is essentially first compute dr dgdb, right? Dr dgdb, and then the distance. So that's the distance, the current distance. Then we do that, but for the I, right? And if the new distance, how can we call that? Let's call it dd, right? So something like this. If this thing is less than d, we have to update the index. We have to update the index, and it's going to be I, and the distance is going to be dd. All right. So now, okay. Okay, so now let's try to. I need to bring back my code. I need to bring back my code that actually did the RGB iteration, right? So we need to do the RGB iteration. So this is going to be something like r less than 5 plus r g, and then it's going to be b. There we go. And here, let me give it a try. Okay, so what's the name of this function? Find ANSI index, like so. R is essentially 255 multiplied by r divided by 5. 255 divided by 5. 255 divided by 5. Right. So yeah, so that's basically what I want. Rather. So then here we need to reset after each of these things, right? After each of these things. Okay, let's give it a try and see if it's going to work. So what do we have in here? I can see shit in this mist. Okay, so it tried to do something, right? It tried to do something. Let's take a look. Okay, I think that's pretty pogue. So it actually printed the full quad in here. So let's do if 1 0. There we go. And if I try to do it like this, okay, so yeah, that's pretty cool. So on the X in here, right? So let's take a look at that. On the X, we're moving from 0 to blue. This is from 0 to blue. This is X. On the Y, we're moving from 0 to green. So, and this is a gradient. And for each of the square, we increasing red. That's basically what's going on in here. Isn't that cool? I think that's pretty cool. right? So effectively, we implemented 256 RGB support for true color RGB support for 256 terminal, right? So that's basically what we did in here, because we have like this table and we're searching the closest point for the color point that we have, right? So it's a little bit linear, but I mean, for each pixel we just do 256 iteration, which is like not that bad in my opinion. I think that's fine. What do you guys think? Okay. Subscribers of... So, and essentially then we can just take this code and we can already simply copy paste this code to our application, right? And just use it, I suppose. Okay, so here we just have an index, and effectively in the VC, right? In the VC, we have. Okay, so here's the canvas, right? So here's the canvas, and in a canvas we store characters. So what essentially we can do now, we can store integers in a canvas. But to be fair, we can still use characters. Who said we can't do that? We can still use characters because the value we're going to be using there is from 0 to 255 anyway, right? So we don't really have 256, don't we? So let me take a look. Where was that? Where was that thing? So yeah, so we don't have 256. So in terms of representing the pixels in the memory, we literally don't have to do anything. That's actually pretty cool. And by the way, I probably have to put this thing, well, I definitely have to put that in the description. Alright, so this is the 256 colors cheat sheet. Alright, cheat sheet. Okay, so this is actually pretty cool. This is easier than I thought. That's what is kind of weird, right? It is easier than I thought. So let's go ahead and copy paste these things. So we're gonna have a color terminal and this thing that implements this entire stuff. So I'm gonna just put it in here. In place where we call this thing VC term color to char, right? VC term color to char. We do VC term compress pixel, right? Oh, so we actually, okay, this one is a little bit more complicated because we compress pixel chunk. Oh yeah, we compress pixel chunk, but we return RGB, right? We return RGB, and then we convert color to char. Interestingly enough, I think we can have something like uint. Yeah, essentially, we split the entire canvas into chunks of a certain size, and we compute the average color in there. Right, we compute an average color in there, and this is the color that we can use to look up in the table, right? So compressed pixel, right? So here is the compressed pixel. SOC. I don't remember what SOC means. Scaled OC. Oh yeah, it's a scaled OC. No, I need to do this thing. So find ANSI index by RGB. So what we need to do, so let's call it CP, compressed pixel. Olivet's red, CP. This one is going to be Olivet's green, CP. Olivet's blue, CP. There we go. So essentially we have a compressed, like packed pixel, right? So we uncompress the components in here and then we look it up. Okay, so and when we're displaying, yeah, there we go. So when we're displaying, we just put the character in here, but this is not what we have to do, right? So what we have to do instead, let me put, yeah, let's actually comment it out. We have to do that trick There we go. So, and the index that we are gonna be using in there is located in here. There we go. But then, on each new line, we have to put this thing in here instead. So let's actually put it like that. And that should be it, believe it or not. This is the entirety of the implementation. Right. And let us see how it works. So I'm gonna do no build, and I'm gonna try to rebuild like everything in here. Right. I'm actually excited. Okay, so there's non-standard. E is not standard. God damn it. Okay, so probably have to do. I don't remember. Whatever. So I'm gonna fix that later. So. Okay, so we build everything. Everything seems to be working, and let's give it a try. So I'm gonna do demos. First, I'm gonna try to run the demo triangle. Right, so this is SDL, right? So this is the SDL triangle. Let's give a term try. Okay. There is something weird on the edges, that's for sure. So why do we have blue color on the edges? So it's kind of, and also green. Well, I mean, it's trying to find the closest one, but yeah. Huh, that is actually super cool. So this is the original one. So maybe it feels like there is a little bit of an overflow in here. So yeah, let me see. It feels like some sort of an overflow. You know what I mean? It's just like overflow. What if I use uint 6014 here? 6014 in here. 6014 just to be sure, right? You know what I mean? Just in case. Neighbors are doing something weird. All right. Okay, so this is SDL. What about the term? It didn't make much difference, but it's slightly different. It is in fact slightly different. All right, that's kind of close. All right, so let's take a look at other demos. Right, so let's go to the website. Let's actually go in order. I think it's interesting to go in order. So dots 3D. So dots 3D SDL. So this is the demo that we have. Let's take a look at how it looks in the terminal. It looks like shit, to be fair. But this is probably because the scaling is kind of weird. Right, the scaling is kind of weird. Maybe we can fix that. For example, for the teapot, well, I mean, it's too much work, to be fair. Right, so because it will have to rebuild everything. So let's take a look at squish. I'm really interested in squish because we have like an actual texture in here. Right, squish. That's pretty cool. All right, so we can kind of see something, but the colors are off. Triangle 3D, okay. Triangle 3D kind of works as well. So okay, so the most interesting thing is probably the teapot. Let's take a look at the teapot. And as far as I know, teapot also has a higher resolution. So there we go. Here's the teapot. You know what's interesting is that in the original code, we actually put 2 pixels next to each other. Right, to make it, you know, rectangular. So I'm gonna put another space in here, and let's try to rebuild it, I think. Color is weirdly off. Yeah, I know. I don't really know why, though. It is in fact weirdly off, probably because we don't have enough colors, but we have 256, so it has to... So it's really weird. So I don't know. I don't know what's up with that. So maybe the table is incorrect. Maybe something maps incorrectly in here. Right. So maybe something maps incorrectly in here. So this is the index. And if we found something that is closer to the original R in here, so I don't know. Okay, so did we rebuild the entire thing? Okay, so we did. Right, so this is what we have. So this is the colorful, but it's kind of weird how on the edges it has this a bluish color. And it's probably bluish because it's darker, right? Because it's darker. No, yeah. So, and we could already see that with the triangle, with just a simple triangle. Right, so there's something off at the edges. Though the rest of the stuff is correct in here, right? So there's a red, blue, and green. So overall, it's kind of fine. Right. So, but something is off when we look things up. So this is the color table. So this is the new index. So if we find something that is closer, it should work. So the only reason why it might not work, is because maybe this table is not correct. So yeah, but maybe that's how it's supposed to work anyway, with the limited amount of colors. I mean, with the limited amount of colors, this is more or less correct. So I'm registering for 2 hours already, so my brain doesn't work. So I think this is a good result for today's stream. I'm gonna try to see what kind of like bug in there. Regardless of the bug, the general approach is not gonna change, right? It's gonna stay the same. It's just probably something within how we search in here, so it doesn't really change the general approach. My hypothesis is that it's just simply the like too few colors, and we have like a very much sophisticated gradients, and so yeah. Though the color space is not particularly linear. You know what I mean? It is not particularly linear. So we might want to do gamma correction before like trying to, you know, find the closest color or something like that. You know what I mean? So yeah, but in any way, I already spent too much time doing this kind of thing, so that's the result for today. That's the result for today. All right, does anyone have any questions? Bouncing emote. People want bouncing emote. Squish. There we go. So yeah, it's supposed to, there is something definitely off, but I just don't have already brain power to finish it, right? So I know you guys want me to fix and do everything perfectly, but I already do like stream for 2 hours, right? So I did what I can, right? So I did what I can. All right, so 0, 1, I don't know. Find ANSI index by RGB, so red, green, blue. It also gets compressed. It also gets compressed. So yeah, so that's the result for today's stream, right? I think it's a pretty good result. It's a pretty good result. Something is off, but whatever. It's always we can always get fixed. Like we can always fix all of that later, right? So I think software developers should get out of this mindset to get everything perfect first try, because that's not how software is done. Software is done in iterations, right? You basically getting closer and closer to required solutions. I think this idea of getting everything perfect first try is coming from CS education. I think CS education actually ruins software developers, in my opinion. All right, so that's it for today. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you on the next stream. All right, so bye-bye. Love you. Looks like we're live. Hello everyone, and welcome to yet another Zozin session. Let's quickly make a little bit of an announcement and officially start the stream. So, red circle live on Twitch, and what are we doing today on Twitch? We are displaying images in terminal with C. Right, so today is basically a continuation of yesterday's stream, right? So, and yesterday we were working on a very interesting problem, right? So, of course, we continue developing Olive C, which is the graphical library that we started to develop like 3 or 4 months ago, I suppose. Right, so, and one of the things this library has, it has a bunch of demos, right? So it has a bunch of demos, and those demos work on 3 platforms, right? So the first platform is WASM, right? It works in a browser. You can actually find this thing in here. Right, so this is generated by our library, Jesus Christ. Right, so, and we also have SDL versions of those things, right? So let's take a look, for example, triangle, SDL, right? So this is SDL, and there is a third version, the third platform, which is the terminal, right? So, and what we were working yesterday, on yesterday's stream, we were trying to switch from ASCII codes, ASCII graphics to actual colors in the terminal, right? So the terminals have support for colors, like usually 256 colors. Some of them support like proper true color and stuff like that, but my terminal only supports 256 colors, right? So, and this is what we were working on yesterday. So we managed to I suppose this is because of the TeamUX, right? So I think this is because of the TeamUX. If I switch out of the TeamUX, right, so this is going to be Olive C. So build demo, and I'm going to take a look at the triangle, a terminal. Yeah, so it looks a little bit better. So this is basically the terminal color support, but it's a little bit off, right? So it's a little bit off. So for instance, if we take a look at the demo with a texture, right? So here is the texture that is, resizing, squishing and stretching and stuff like that. And if we take a look at the terminal version, we'll see that the colors are completely off. So and the reason why all of that is completely off is because of how we compute the distance to the closest color, right? So we have 256 colors, right? So, but all of the images are generated in 24-bit color, actually 32-bit color with alpha, but we're ignoring the alpha because it's not really useful in a terminal. Right, so, and essentially we have a 256 color palette, and we need to do something, like we need to somehow convert 24-bit colors into 256 colors palette. Right, and the way we do that, we have a table. We have a table of RGB values of these 256 colors. Right, so I might as well even go somewhere here. Right, there we go. So this is basically the table, right? And every time we need to display a color, we take the current color, the true color, and we go through this entire table and try to find the closest color, and we use that closest color, the index of that closest color. So the way we compute the distance, right, to find the closest one is actually pretty straightforward. We're using Euclidean distance. We treat RGB as XYZ space, right? We literally do take the differences, the sum of the squares of the differences between the points, and then do square root. In fact, I don't even do square root because I'm just comparing the relative distances. So square root is actually kind of optional, right? And it kind of works in a weird way, because if you take a look at the RGB space, In fact, one of the demos that we have kind of displays the RGB space. So if we take a look at the dots 3D. So with the dots 3D, we're doing a very interesting thing. So you may notice that one of the corners of this cube is actually very dark. And this is because this is RGB cube. This is straight up RGB cube. So here you have 0, 0, 0. So in that axis goes red component, in this axis goes green component, and in that axis goes blue one. Right, and this is basically the RGB space in 3D space. Right, so this is basically what we're doing here. And if you calculate the distance within that space, right, essentially, if you have a point, right, if you have a point in that space, the closest point to that space might be actually in a sphere. So that means you may have the closest point which is yellow, but then on the opposite side you can have the closest point which is blue. Right, and they have the same distances even though they're completely different colors. And this is probably what's happening in here. Right, so what we're supposed to have in here is like a peach color, which is kind of close to yellow, right? So this is a peach, and this is a blue. Right, because if you take a single point and they're on the opposite sides and they have like the closest, the same distances in RGB space. So using like Euclidean distance in RGB space is actually kind of a bad idea. Right, so unfortunately that didn't occur to me on the stream. Right. So, but then, like after the stream, after I had a break and stuff like that, I realized why this is happening. So yeah, the question is, what would be a better solution? What would be a better solution? A better solution would be to actually compute the distances not in RGB space, right, but actually in something called HSL space, right? So there's a different way to represent the colors called hue, saturation, lightness. Why is it in Russian? Anyway, so I can just click on Russian and maybe switch to English. It's just like, come on. All right. So essentially, HSL, by the way, is actually a very cool color space. I use it every time I actually pick the colors for my thumbnails or when I'm drawing something. So as far as I know, HSL is a better way to reason about colors for humans than RGB. RGB is great for storing the colors, right, because of the technical reasons and stuff like that, but HSL is good for human reasoning about the colors, right? Hue is basically the base color, right, literally pure base color, whether it's a pure red, pure yellow, green, blue, and stuff like that. This is a base pure color. Saturation is how much of that color you have, right, how much of that color. So the less saturation, the more it's going to be grayish, the more it's going to be I forgot the verb, I'm sorry. The more it's going to lack the colors. And lightness is how bright it is, right? So, and essentially by manipulating these three parameters, you can basically like construct any color. And for humans, it is easier to reason in terms of HSL rather than RGB. And this thing, I think, is better for finding the closest color, right? Because first you will have to find the closest hue, the closest pure color, and hue is probably going to be the most important sort of like parameter of the distance. Then you want to find how much of that color you have there, saturation, and saturation is probably less important than hue. You have to get the hue right, then the saturation, and then the least important is probably lightness. And what I want you to do on today's stream, I want you to try to use HSL instead of RGB to find the closest point and see if it actually solves the problem of this stuff, right? I'm blue, double G, double die. Alrighty. So let's go ahead and try to implement that. So I already downloaded the colors in here, right? As you can see, we constructed this RGB table from this thing that we downloaded from here somewhere. I think, yeah, 256 color cheat sheet. All right, and I think I just need to construct another one, another table which contains the HSL. Right, so here I have a simple utility. This is not a demo, this is just a utility where I experiment with this entire stuff. Right, so I think I'm gonna continue developing this specific utility. So this is a color table RGB 256, right? So, and let's try to compile that and just go through all of the places where we refer to that table and just fix all of that. All right, so clang o color.c. So let me go here. So this is a color table, RGB. Maybe I'm gonna actually do query replace for all of this stuff. Right, so query replace color table, RGB 256, and let's go ahead and just like recompile this entire stuff. Cool. Okay, so let's try to construct HSL now. Right. So let me do cut on the colors txt. Right. So what we want is 1, 2, 3, 4, 5. I'm not quite sure actually. Let me open the colors txt. We need to extract the corresponding column. Right. 1, 2, 3, 4, 5. Okay, so let's actually use cut to get the field 5. And there we go, so we got the HSL in here, right? So quite interesting is that the hue is usually described in degrees. So hue is sort of like on a color wheel, right? It's on the color wheel, and saturation is in value is in percents, right? So we have to keep that in mind. So here we have like a 100% of saturation and 50% of lightness, right? If both of the, I think, I don't know, if you have 100% of lightness and 100% of saturation, do you get the pure color? I think it's not gonna be pure color, but anyway. Okay, so let's actually do a little bit of the automation, right? So we want to basically construct a C array out of these things. So let's go ahead and just like use regular expressions to cut out not important things. First of all, I want to get rid of the HSL in here. Right, so let me actually find HSL and I should be able to get rid of that. So the next thing I probably want to do, I want to extract the components of the HSL color, right? So let's actually do them like that. So this is the first one, this is the second one, something like this. I think we don't have a space in here. Right, so and then we're gonna have this one. And let me put them in some sort of a C array, right? So because we're programming in C, so this has to be a C array. And that kind of worked. Unfortunately, % in C means a mod, and this is not what we want in here. So I might as well actually get rid of that by putting it in here. I hope it's not a special character in regular expressions. Okay, so that's pretty cool. Right, there we go. So we managed to extract the HSL colors, and now we are able to copy paste them in here. So we have our RGB in here, and we're gonna have HSL color table, HSL 256. All right, so there's the 3 components in here, and I'm gonna copy paste all of that in here. There we go. How about that? Isn't that cool? All right. All right, so I'm just looking at the chat. Maybe there's something interesting. All right. Can you advise where to learn regular expressions? I don't remember where I learned regular expressions. I think I learned them by just messing with random examples and reading random stuff on the internet. I don't think I had anything specific. There is a whole book written on regular expressions. Regular expressions book. I never read it. So, but I heard people say that this is a good book to learn regular expressions. I learned regular expressions the same way I learned C, but just by Googling random stuff on the internet. There's a lot of also like things for parsing regular expressions, for experimenting with the regular expressions, like regex 101. Right, so this thing compiles regular expressions and actually highlights these kind of things. Okay, so I'm gonna actually give the link to this sort of book. Right, and there's things like regex 101. Regex 101 is not the only thing that can do this kind of stuff. There's all sorts of services like that. Like people constantly create a new one because it's such a cool idea. So imagine that we have something like HSL. Let me find the colors.txt. Right, so let's actually copy paste this entire thing in here. Right. So here you can put some sort of input, and then here you can start typing down a regular expression, and it will automatically like highlight what it found. Let's actually put HSL in here. Right, and it, as you can see, it extracted HSL. Right, so then I can put parentheses in here, and it couldn't find anything because there's nothing between parentheses, and there's no such thing in here. Then I can say, okay, between parentheses we have any character of any amount. And there we go. So we match these things. So dot means any character, and the asterisks mean that everything before this thing, like any 0 or more of these things. And since dot is any character, it means that like you have any characters in here. But we want to actually extract all of the 3 groups in here. So we may want to start matching them like this, right? And let's actually put it like that. Boom, boom, right? And that should actually... I don't really know, so different regular expressions may have different syntaxes, right? So this one doesn't really work the way I expect it to work, so maybe... but it kind of worked, right? So can I actually do something like this? Oh yeah, there we go. So some regular expressions require you to backslash the parentheses. Some of them require you to backslash them when you capturing groups. So there's different dialects and stuff like that. So in this one, this means parentheses and stuff like that. Right. So this is another way to practice regular expressions, right? Because you can interactively see whether you type in a correct thing or not. Right, something like that. There we go. So it automatically highlights. Some of them even explain to you like what all of that means. So that's basically 2 things that I recommend you to learn, to use to learn about regular expressions, even though I never read the book itself. Right? So, but I heard people say that the book is good. Right, so this is regular expression interpreter, or I don't even know how you call this kind of website, right? So it's just a regular expression experimenting tool, and here is the book on regular expressions. So I'm going to also put that in the description for anyone who's interested. Anyway, so yeah, regular expressions are kind of painful, but they are pretty much ubiquitous, so you need to know them, right? So it's like JavaScript. It's not great, but it's everywhere, so you have to know it. That's basically the same logic. Anyway, so here's the thing. So here we have find ANSI index by RGB. Okay, so let's actually create something similar, like find ANSI index by HSL, right? So in here we're going to provide H, S, and L, right? And we'll have to implement that at some point. I'm going to actually put assert here, something like to do. Not implemented yet, right? Because first thing we need to do, right, before we implement that, we need to be able to take RGB and convert it to HSL. Without that, it's kind of like pointless, right? So let me actually try to compile this entire thing. So there we go. So it doesn't compile because we have some weird stuff, some really weird stuff, which I'm not really... Ooh, some of them have like a leading zeros. That's actually very cool. And yeah, in C, if you have a leading 0, it's actually interpreted as octa 8-based. How do we call that? So what does it say in the error? Octal constant, right? So basically, it's an 8-base number system, right? So it's an octal-based number system. I don't really know how to pronounce it properly. So, and that is rather interesting. So how many of them do we have? Can I just go through all of them manually and just fix them like so? I really hope we don't have too many of them. Okay, so we don't really have too many of them. That's nice. So let's put a certain here. There we go. Base 8. Okay. So how do we convert RGB to HSL? So let's actually Google that, RGB to HSL, because it's actually kind of involved formula. Right, so let me see, there we go. So that's the formula, right? So that's how you convert RGB to HSL. So let me see if we can quickly just implement that. Right, so we need some sort of function, RGB to HSL. So here we're gonna accept RGB. And we probably need to return something, but I'm not sure. Do I want to create like a separate structure for that? I don't feel like creating a separate structure. So let me actually pass all of that as a pointer, right? So it's going to be HSL L, right? And we're going to do it like that. So the first thing we do, we divide RGB by 255, right? And the reason is because we need to convert them from the range of 0 to 155 to 0 to 1. We're basically normalizing all of them, right? So, and because of that, this is going to be float, right? So let's actually do R01, R divided by 255, and I'm going to say that I'm dividing it by float to trigger automatic conversion, right? So query replace G. I want to just query replace this entire thing. There we go. And let's query replace G with B. There we go. So we have R, G, and B. So, and after that, we calculate the maximum and minimum. And I suppose this is important for like lightness and saturation and stuff like that. And also we compute the difference between the minimum and maximum values, right? The maximum and minimum values. So how are we gonna do that? So probably we're gonna have something like C max and R01, right? So if G01 is greater than C max becomes G01. So this is the first sort of thing. And if B is greater than that, we're going to assign it again. Right, so this is basically computes the maximum value. And we can do the same thing for the minimum value. Right, so this is going to be minimum. I might as well actually query replace max with min. Boom. And in here, we'll probably have to change this stuff to less. All right, what's going to be the next thing? The next thing, we need to compute the delta between them, right? So maximum minus minimum. Okay, so this is going to be float. Delta, C max, C min. Maybe I'm going to actually split my screen into two so I can see shit. Okay, so hue calculation is a little bit involved, not going to lie. So essentially we have this thing. I wonder if I can make it a little bit bigger just for you. Right, so can you see something? It's actually kind of like yeah, the quality is great, as you can see. Right, the quality is great, but that's the shit we have to deal with on this channel, right? Alrighty, so basically if the delta is equal to 0, the hue is going to be 0 degrees, right? And what's interesting is that if delta is equal to 0, that means the C max and C min are equal, right? And they're only equal if R, G, and B are equal to each other, right? And when they are equal to each other, that means it's gray. And in that case, that means the hue is like nothing, right? I suppose that's what it means. So now, if delta is equal to 0, right? So it's kind of bad to compare these things exactly because it's floats, right? But I suppose if these things are truly like equal to each other, I guess it makes sense to, well, to be fair, maybe it makes sense to actually have some sort of epsilon, right? So essentially, if delta less than epsilon, right, some sort of epsilon, only then consider it to be equal to 0. And epsilon, we can say, is equal to 1 minus 6, right? Something like that. It's basically 0, 1, 2, 3, 1, 2, 3, right? So this is what it's equal to as far as you can remember, right? So this is a very small value. If it's less than that value, we can safely say that it's basically equal to 0, right? And in that case, the hue, right? The hue is going to be equal to 0, right? So otherwise, if C max is equal to R, right? So we probably also want to do the comparison with epsilon. right? But I think it's not particularly required because we're literally assigning R01. We're not doing any mathematical operations on that, and if Cmax is literally equal to R01, it's going to be bit by bit equal to the original value in here, right? So I think we can quite safely just like compare it with equals, in my opinion, I think. Right. So in that case, we have to find the difference between green and blue, right? So let's first do that. G01 minus B01, and we have to divide it by delta. And also we have to do that by modulus 6. To do this kind of stuff with float, I think we have fmod. Right, so and we're gonna put 6 in here, right? And this is the value. We also have to multiply by 60 degrees, I don't really know why, and this is our hue, right? So this becomes our hue. I wonder if I can just make the line a little bit bigger, because I want to be able to have this specific size of the font. Alright, so if Cmax is equal to green, G01, what hue is going to be equal to? So we have a difference in blue, B01 minus R01, and here we divide by delta, but not by module 6 for some reason, and then plus 2, and then we also multiply that by 60, maybe. I have to do it like this. There we go. So this is what we have, but I didn't put a multiply. There we go. So otherwise, so this is a Cmax, Cmax equal to blue 01. In that case, hue is going to be equal the difference between red and G, right? R01, G01 divided by delta, but plus 4 this time. 60 multiplied by that, and there we go. Okay, so interestingly enough, so what's gonna happen if we have like a else branch, right? So this one has to be if, by the way. So let me make it a little bit bigger one more time. So I suppose maybe we should just say that this specific place is unreachable for now. If it is reachable, we'll try to see what is going on in here. So for now, I'm gonna just mark it as unreachable. Okay. I'm gonna just mark it as unreachable. Cool. So we have hue, right? We have hue. So saturation. So the next thing is saturation. Saturation is pretty straightforward. We only have like 2 branches in here. Right, when delta is equal to 0, well, we can actually quite say that it's less than epsilon, right? What's interesting is that we don't have to worry about delta being negative, because we always subtract the minimum from the maximum, so it's always going to be positive, right? So we can just like use the original value without any absolute or anything like that, right? So in that case, the saturation is going to be equal to 0. Otherwise, saturation is going to be equal to delta divided. I'm not sure if it's visible particularly for you, so I'm gonna just like increase it in here. Hopefully you can see, even though the quality is quite crappy, but that's fine, right? At least it's readable. So 2L, what is L though? Where is the L? Oh, it's lightness. So they expressed the saturation in terms of lightness, but they defined lightness later. I'm not sure. Okay, could have actually defined it first. So we can just say that L is going to be equal to Cmax plus Cmin divided by 2. Okay, so there you go. And then in here, the saturation is this thing, 2 multiplied by lightness. God damn it. Right, so probably have to do something like this. Minus 1. Right, and I guess that is basically it. Right, I think so. I think that's basically the conversion. But there is some problems in here, because all of that in floats, but we expect the saturation, the HSL, to be in integers. So maybe I'm gonna just put this in floats for now. All right. Isn't a bug? Isn't a bug? I think it's pretty freaking bug. So let's try to compile this entire thing and see if it fails or not. Okay, so we have a couple of things in here. Fmod is not available, so let's include the math, and we probably need to link with the math library as well. So as you can see, now it works. I'm actually really curious if my HSL thingy works correctly. And what's funny is that we have RGB colors, the corresponding RGB values of the same colors. What we can do, we can actually go to RGB colors, convert them to HSL, and compare them to these HSL values and see how they compare to each other. I think it's a pretty good idea to just test things out. Right. So I'm going to create a separate alternative entry point. Right, so something like this. And let's just go ahead and iterate through all of the colors. Right, so 256 plus I. So here, RGB to HSL. So I'm going to provide table. What is it? What I think it was called color table. Color table RGB2. I think the color table RGB 256 is really long name. I don't really like it. Let's actually rename it to something like RGB 256. Yeah, so it's a little bit shorter. And the same with HSL. Right. Yeah, boy. That's cool. Okay, so let's go to main. So in here I can do RGB 256. Right, so this is the index, and I take 0. Right, so this is that. And then 1, and then 2. Right. So, and I need some values for HSL, H, S, and L. And I'm going to provide the pointers to those things, H, S, and L. There we go. Okay, so, and let's just like literally print them and compare them to what we originally have, right? So, we can put this stuff in here. So this is the original like values. So they're integers. I know that there are different type integers and floats, but I do that intentionally. Right, so just to compare things, just to see visually, right, like to get an intuition whether we're doing everything correct or not. Right. So in here, I'm going to copy paste this stuff, just put it in here, but I'll have to replace RGB with HSL. Boom. Alright, and then I'm gonna put HSL in here. So on the left, we're gonna have whatever we got from the website, from the table, right? And on the right, whatever we managed to convert from the RGB from that same website, right? And let's actually compare them to each other. Right, so let me see. So this is the course. Okay, that's pretty cool. Okay, 0, 0, 0, 0, 0, 0, 0, 125, 0, 1, 0.25. Okay, so here we have in percentages. So on the original website, if we take a look at the colors.txt, all of them use percentages from 0 to 100, but our percentages are from 0 to 1. So we have to keep that in mind. Right, so essentially, if we want like a proper thing in here, we probably need to multiply them by 100, right? So to get them to the actual thing in here. But I'm actually quite surprised that it's pretty freaking close. Right, so let's actually pick a random. Okay, 777. Okay, so these are they really degrees? Some of them work, some of them don't. Wasn't that 7 thingy? When they're really small, some of them even negative. Damn. But maybe it works out, who knows. Okay. So maybe one of the things we need to do with this degree stuff, because we want to have values from 0 to 360, right? We can do fmod. Does fmod work with negative values, right? Can I do fmod 360 and just hope that it's gonna work with negative values? Okay, so, well, I mean, this is not where I had to do that, so I had to actually put fmod on a different thing in here. There we go. So this is going to be HSL fmod F 360. Right, there we go. Can I do fmod? No, it doesn't work. So it basically works like an integer mode. Right, so it works like an integer mode. So probably we have to solve this thing the same way as we solve it with the integer fmod. So basically by adding 360. Right, but that actually creates a situation that basically creates incorrect values for positive values. So we have to do fmod f second time. Right, so there we go. And that should kind of wrap it properly, so there should be no negative values anymore. Right. So I'm actually kind of surprised with these values, some of them like 3 and stuff like that, but maybe that's not important. Okay, good. Okay, so we'll see. So I'll keep that in mind. So some of them are not correct. Maybe we shouldn't even use the HSL then. It's hard to tell. Though 90 degrees maybe like... We'll see. Okay, whatever. And all of that probably have to be integer, right? So since the values that we have in a table are integers, we probably want to keep all of that as integers. So let's actually mark this thing as floats, right? So these are the floats. And let's create the integer values of HSL, right? So this is going to be this stuff, right? Integer S, so this is F, this is F, and the lightness is gonna be like that, L, LF, so this is H, S, and L. I'm gonna put it in here, so, and the F here has to be an integer, there we go. So it probably, well, I mean, I assign it to integer, so it will automatically convert everything. Okay, so that's cool. So semicolon, no big deal, no big deal. And overall, yeah, they're kind of close, except for this kind of situation, but this could be like a close values anyway. Right, it could be close values anyway. Right. So, okay, that's cool. I wonder if we can embed this kind of conversion into RGB to HSL, right? RGB to HSL, right? So I can take this conversion like so. So essentially here we can say, okay, this is going to be an integer. These are the integer output values. And whatever we do in here are going to be intermediate values, right? So this is C main. So let's actually say that here I'm going to have a float which is like hue, HF, right? And I'm going to query replace H with HF, like so. There we go. All right, so then we have an assert in here, then we have an intermediate LF, right? So this is an intermediate LF. And in here, we're going to have an intermediate SF, right, which is initially 0, but let me quickly replace SF, like so, and this one is LF. And then here are going to be the output values. There we go. So we basically embedded all of that stuff in here, so we have some warnings in here. So those things must be integers. Int HSL, H, S, and L. So H, S, and L. Put that in here. And I can't see shit in this mister, so yeah, there we go. I can see it now. Okay, cool. Alright, so now it's embedded into that original function, RGB to HSL, so it's all in integer. This entire thing is probably very slow, but I don't really care about it right now, so what I care is about to actually work in here. Okay, so we have some sort of a conversion and stuff like that, which is kind of cool. So you know what I want to be able to do? I want to actually test that on an actual image. What if we turn this utility into something that accepts an image and just prints that image in the terminal? I think this could be an actually pretty cool tool, right? So you basically give it a file, a PNG file, and it just like prints it into... I'm pretty sure somebody already done it before, but I mean, we can try to do that as well, because we can quite easily load the PNG image because we have STB image, right? So let me see. So we have some dev dependencies, right? So dev dependencies. So here is STB image. so why is F in the chat? Okay. Right, so we need to do stbimage.h, define stbimage implementation. I suppose that should work, hopefully. stbimage, well, we have to probably provide the def dependencies. How is it called? It's called dev deps, but I can't easily do that. Def deps, there we go. Okay, so that's pretty cool. Okay, so here's the main function. So let's accept the arguments argc, char, argv. Right. So let's make it accept the file path. If argc is less than 2, right? If argc is less than 2, we're going to do what? We're gonna say fprintf std error. Error, no input is provided, right? And then we're gonna just exit with 1, right? We're gonna exit with 1. So, and then I'm probably gonna accept the file path. I'm gonna accept the file path, argv1, right? You know what, I think I want to make a small break. I ran out of tea and it's pretty cold in here, so I really need something warm, so let's make a small break. Alright, so some people pointed out that even though the compiler complained about invalid octals, we still probably have valid octals somewhere there. Right, so let's actually try to get rid of them. So let me go to the color.c. And let me find, so there's things like 07 and stuff like that. So the really valid octals probably consist of leading 0 and then 2 digits afterwards. And we don't have such things, right? That's the problem, we don't have such things. So we have a leading 0, then a bunch of numbers in here, and then maybe only 1 or oh, so maybe we don't even support that syntax at all. So I wonder if I can just use the regexer or regex 101 to test these things out. Speaking of how this website is useful, right, so we already discussed that, because some like different editors or different tools have different you know, dialects of regular expressions, right? So sometimes it's just easier to use a different thing. So here is the digits in here, so this is leading 0, and then we say that we have 2 of them. And do we have any of those things? So I suppose not, right? So what about a single one here? Right, so yeah, we do have a situation, but we can probably say that this must start with a word. Okay, so there is a valid octal thingy, but they are the same values anyway. Octals, I swear to God, the syntax for octals is so bad. Like, why don't you just make it 0, O or something, so you so you can have leading zeros? It's just like, oh my God. Anyway. The table from the internet is wrong. Okay, it is what it is, but it's right for some colors. It's right for some colors, and maybe we're gonna just stick with that table, and we can try to find a different table later, right? So because I don't want to spend too much time on like finding the correct table right now. So this one has some of the correct values, so let's just work with them, and then we'll see. The 07 one should be 207 is missing digit. Maybe we can, you know, I think we can actually fix that up a little bit later. We can basically regenerate HSL from RGB at runtime, and then just use this HSL table, you know what I mean? Right, so who needs the internet if we can generate our own shit? I mean, we still got the RGB table from the internet, but anyway, so let's not obsess over that thing too much, right? So it's kind of like pointless to obsess over that thing of like before we even have any working code. Let's just have some code and see how it goes. Okay, so first thing we need to do, we need to load an image, right? But yeah, thank you for pointing that out. Thank you. Like, this is a very valuable input. I really appreciate that. Okay, so let's do stb image image load, or maybe stbi load. I think that's how this function is called. There we go. Oh, so this is pixels, right? But the pixels are going to be inserted too. So the file path is this, and this is going to be width, and this is going to be height. So this is the amount of components. I don't care about the amount of the components. I say that always convert it to 4 components, right? So this is width, and this is height. There we go. So if pixels were null, that means we couldn't load the image. So we have to report that. Std error. Could not read file s file path, and we're gonna exit with non-zero exit code. So we got the pixels. So essentially what we need to do, we need to just iterate each individual pixel and get the index and just like use that index. Kind of similar to this one. Find ANSI index by RGB. Right. So okay, that's cool. So I'm gonna start iterating rows from 0 to height. This one has to be small. For x equals 0, x less than width, plus x. Right, and then let's get the pixel. So this is pixels. Y multiplied by width plus x, and there you go. So we probably want to get the RGB values, right? So let's do R. So this is FF, right? So we extract in FF. This is a single pixel. G is basically shifted by 1 byte. You can say that this is shifted by 0 bytes. Right, and this one is shifted by 2 bytes or something like that. So this is RGB. The next thing we need to do, we need to convert it to HSL. So RGB to HSL. And RGB HSL, and there we go, we got HSL. So we need to utilize that function, find ANSI index by HSL, right? HSL, H, S, and L, and this is the index, and we probably need to print this entire stuff like so. I might as well actually replace this stuff like that. HSL, boom. So this is that, and then we need to also reset on each individual row, like so. So I want to actually keep this thing because I believe it is useful, right? Like so. Okay, so and this should theoretically convert the image into the like ASCII code color things, right? But we need to implement this stuff, right? We need to implement this stuff. We need to iterate through all of the HSL values, right? All of the HSL values, and just find the closest one. All right. So 0 less 256 plus I. And so we originally have an index, and we just need to compare the distance. I have an idea. What if we have something like distance HSL 256, where I just provide index HSL, right? And I see, okay, if the one that we found here is less, right, we just assign index to I. Right, so I think this is actually pretty good way to do that. Right, so this is integer, and this is integer, this is integer, this is integer. There we go. I have to implement this entire thing. I'm gonna copy paste that stuff, put it in here, and here we just return the index. There we go. So find index by HSL, right? And the question is how we're gonna be computing all of those distances. All right, so we need to find the differences of hue, saturation, and values, right? So it's going to be DH, H minus HSL 256 of I, and then we have to do S. This one is 0, this one is 1, and this one is L. This can be 2, right? And we're gonna just use the square thingy, right? Similar to, so we're still using the Euclidean distance, right? Euclidean distance, but in a different space, not in RGB, but HSL, right? So for now, I'm gonna give the importance, the same importance for all of the components, even though there's clearly some gradation, some biases. Like in my opinion, hue is more important than saturation, and saturation is probably more important than lightness, but I'm not sure about these two, so we'll see. Maybe we're gonna put some sort of a biases on these things, and hue should contribute more into the distance than the saturation and the lightness. Right, so this is what we're gonna have, and let me try to compile this entire thing. Okay, so what do we have? Pixels, incompatible pointer, so we probably wanna cast it explicitly, right, because that's C. Okay, so it wants the input. Let's provide the input. So I have Tsodin Pog in here, right? I'm sorry for the quality. Okay, let's do color. Color. The fuck? I just first tried this beer. What the fuck? Look at these colors. I mean, okay, so let's actually make the proportions a little bit better. So let's actually put a space in here. Okay, so I mean, I'm not complaining. That's freaking perfect. Even with fucked up colors, like it just worked. The fuck? Okay. That's pretty cool. And this is a terminal, right? So essentially, I just need you to zoom out, like far away. If you zoom in, you can clearly see that this is the terminal, right? So here is the text in here. You can see. But if you zoom out, this is like an actual image in here. And that's pretty cool. So you can actually provide like different things in here, right? So we have a Tsodin cup, I suppose. And Tsodin cup, okay, so it's a little bit fucked up because we don't handle the alpha, right? We just don't handle the alpha properly. We probably need to do something about that. But yeah, who needs open? Yeah, exactly. So, okay, so let's actually try to handle the alpha properly. How can we handle the alpha? We need to get the alpha in here, right? So it's going to be pixels 24, 0x. FF. So maybe here we have to do something like this. So this is going to be 0 byte, this is 1 byte, this is 2 byte, and this is 3 byte. There we go. So this is alpha. Okay. And essentially alpha is a value from 0 to 255. So we want to convert it to 0 to 1, right? And then we need to multiply it by R, right? So but we may lose some information, so we have to first do multiplication and then division, right? So this stuff effectively will also apply alpha on all of these components, and if alpha for some of the things is going to be 0, it's going to cancel out everything in here, right? So this is basically what I'm trying to do. So I'm taking alpha into account. So here we probably have some pixels in the image that have 0 alpha, but the garbage as R, G, and B. So that happens sometimes. Some of the graphical editors like do that. Essentially, like they remove some of the pixels by setting their alpha to 0, but not setting R, G, and B. And sometimes you can even see some hidden images in there. I even have an example. For example, the debated emote of Twitch has a lot of weird stuff in the background, which is hidden by alpha. But by ignoring the alpha, you can actually see that garbage. So let's actually see if this works, and I'm going to demonstrate you. Okay, so let's recompile this entire, and as you can see, it works now. So we took into account the alpha, and now everything's fine. If we ignore the alpha, if we only use the R, G, and B, it's going to have this garbage in here. So let's actually take a look at the debated, as I promised, right? So let me find gbaited. Long we've been waited, let's not get gbaited. So I'm going to wget o gbaited png, right? Gbaited png. Hopefully it will download everything properly. So, and let's take a look. So this is fair gbaited. Okay, so this is the image. Right, and I'm gonna try to apply it to my tool. You'll be able to see that there is a lot of weird stuff in the background for the gbaited, and also there is like weird colors. But yeah, so like what is that in the background? Because the background is supposed to be transparent, but there is a lot of stuff in here, right? But if you actually take into account the alpha, right, so we have to recompile it, of course. I have to recompile. It looks fine, right? So that's pretty cool. So let's take a look at some other things. What other assets do we have in here? Web PNG. So we have the image, the logo of the library itself, right? Do you guys know that the library has a logo, right? So it's this. I'm not sure. I kind of fucked up the logo, but I mean, it's all right for now, at least. And oh boy, I guess this is where the copy-paste error starts to shine. So it's an eggplant. Yes, it's an eggplant. Anyway, so let's try to see. What I was thinking is that we can try to generate HSL from the RGB. So let's give it a try. So we loaded everything in here, and let's just initialize the palette, right? Let's just initialize the palette, and what I'm gonna do, I'm gonna just do HSL to HM56. So essentially, I'm taking RGB table, and I'm converting to HSL and save it into HSL. Right. So this can be 0 H. I might as well actually do something like HSL to HM56 I0. Is it gonna be good? Is it gonna be good? Is it gonna be sufficient? I think it's going to be sufficient enough. So this is gonna be 1, and this is gonna be 2. There we go. And we don't even need to do that. Look at that. Isn't that Pug? Isn't that Pug? I think it's pretty freaking Pug. Let's keep it a single line. All right. So let me see, and yep. And so yeah, it was a copy-paste error. So Alexor was right. This is a literally copy-paste error. So, but we recovered the original code from the RGB table. So something wrong with HSL table. So, and I think it's a reasonable solution, right? Just like at runtime, generate the HSL. We can actually print out the HSL table and just recopy paste it back, so we don't have to do that. Oh yeah, by the way, since we fixed the colors, like maybe gbaited is not gonna be weird anymore. That's actually pretty cool. So yeah. Damn, look at that beautiful gbaited. Damn. That's a beautiful gbaited. Alright, so let's take a look at other things. Maybe asset sodium pog PNG. There we go. Look at that beautiful sodium pog. Alright, do you guys have any suggestions on what emote to render in the terminal? Do you have any suggestions? Suggest emote. Post your emote in the chat, and I'm gonna render it in the terminal just for you. Okay, Pepega, of course. Let's do Pepega. Alright. I like Pepega. Pepega is my spirit animal. Alright, so this is gonna be Pepega PNG. Pepega PNG. Okay, so let's do color. Boom. Yo, look at that beautiful Pepega. I think we need to scale down the images. So let's actually try to work on that. But as far as I know, how can we do that? So there is a STB STB library for resizing the images. We can try to use that one. You know what I mean? Alright, so let's give it a try. I'm gonna go to Sodin. That's pretty Sodin, it's nothings. Nothings STB. Oh, by the way, Cup of Pride is also a cool one. We're gonna check it out a little bit later. Lumis XH, thank you so much for subscription. Kosaban, thank you so much. Oh, okay, so it was yesterday actually. So you are the first subscriber for today. Okay, so here's the image resize. Okay, so I'm gonna take the library raw. Here on the setting channel, we're taking the libraries raw. Okay, so wget, and I'm gonna just download the STB image resize. I have no idea how to use it. I use it only once, and I use it on like in a completely different language in Jai, right? So I didn't really know how to properly do all that. So we have input pixels, so resize you int 8. Okay. Well, I mean, sounds reasonable. So we need to, one of the things we probably want to do, we want to preserve the ratio of those things. We want to preserve the ratio of the image, but we want to scale it up a little bit higher. Cup of Pride not illegal in Russia. It is illegal in Russia, but here is the thing about Russia. The laws in Russia don't work. They're sort of like a recommendation on what to do. So they're usually used if you, for example, if somebody who's very important in Russia don't like you, they have a all variety of laws to use as a tool to actually bring you down, put in jail and stuff like that. But unless you're not messing with anyone important in Russia, nobody gives a shit about you regardless of the laws. So this is how laws in Russia work, right? So telling you all of the secrets. So yeah. And if they want to put me in jail, they don't even need me to use this Kappa Pride emote. They will find something else, right? So it's like it's just yet another tool to put people in jail, right? So nothing more. So that's how Russia operates. So Russia has a lot of like laws that even contradict to each other. Like we literally have laws that contradict to each other. But that somehow works because they are a recommendation, right? This is how laws in all Slavic countries work. Ah, okay, so that's, okay, Russia is not unique in that regard. Okay. I don't know, like I feel like, do I want to spend time resizing this entire thing? It probably makes sense if I want to turn it into a tool. Right, into a tool that I can then upload it for people to play, and maybe that's valuable, right? So I do believe that it's valuable, right? But one of the problems is that I have to preserve the ratio, right? I have to preserve the ratio. That means I need to do a little bit of a math that I don't really want to do right now. And yeah, it would be kind of cool if I could just like tell this thing to, okay, so just preserve the ratio. Okay. For some reason I'm not in a mood of doing the math, but it looks like that's what I have to do. Okay, so let's put some to do. Hard code the fixed table, right? So essentially what I need to do in here, I need to generate this table and copy paste it back, so I don't have to do that one more time. So let me find. Okay, so resize. I want to find the actual signature in here. All right. So this is useful. So width. Let's say that we always want the width, let's say resized width, to be 80. Right, we always want resized width to be 80. Then we have resized height. So, and essentially, we need to take the height and multiply it by the ratio, right, of height to width. Right, so this is the ratio of height to width. Oh yeah, so it's essentially height divided by width, and this is a percentage of height in width. Percentage of height in width, which I need to multiply by 80. Right. I hope I didn't fuck it up, right? I hope I didn't fuck it up, but I always fuck up this math. So that's the problem. I always fuck it up. Right, we'll see. If I fuck it up, it will be more or less obvious. Okay, so the next thing I need to do is I need to allocate enough resized pixels, right? So this is resized pixels. So I'm not sure about this particular part, right? So it might be completely wrong. Right? So let's allocate uint32t. So this is a resized width multiplied by a resized height. And of course we want to make sure that it's not... Well, I mean, usually on the modern systems, malloc will never return null, but who knows, like maybe you want to run it on old system, but just assert this is what we're assuming here. So okay, input pixels is going to be just pixels, right? So this is going to be width, and this is going to be height, and a stride in bytes is size of uint32 multiplied by width, so that's the stride. The output is resized pixels. Resized pixels. So then resized width, resized height, and then the output stride is effectively this, but also with a resized width. And then amount of channels is 4, of course. Right. So I'm not sure like why it needs to return anything. Okay. So here we initialized the table, and here we're trying to render the thing. So we have to use the resized height and resized width. So let's do resized. And I'm gonna just put this stuff in here. So this is resized width, this is resized pixels. Width and height, pixels, and there we go. Okay, let me try to compile this entire thing. So implicit declaration, probably need to include stb image resize.h, and in resize deps resize implementation. So let's just copy paste this stuff, bruv, let's copy paste this stuff. Okay, so oh boy, so it wants unsigned integer, right? Unsigned int pointer, and this mother flipper also wants unsigned int pointer. Incompatible because this one wants to be const. Sure, want it to be const, it's gonna be const. Oh, it's character. Sure. Are you happy now? Okay, cool. Assertion. Not equal. No, of course. Of course. And it kind of worked. Did it work? So it's actually 80 characters. I think 80 is probably too much. What about like 40? Let's make it 40. There we go. So it's pretty pogue, but something is wrong with regards to height, I suppose. See any problems though? Oh yeah, okay, so this has to be maybe I just need to use the resized width in here, right? So to make it like proportional and stuff like that. Okay, so that's basically it's kind of like pixelated, but I mean, yeah. Gpated PNG. And this is because we don't really have that big of a resolution anyway. Right, sodium pogue, This is a Tsodin Pog. We can make it like maybe even 20. Let's make it 20. Right, so it will become rather pixel, but I mean, it kind of works, you see? Right, it kind of works. I think something like kappa would work rather well. Right. Kappa. Copy this one. Right, because kappa is already pixelated enough. Right. Kappa PNG. There we go. A color. Kappa PNG. Yeah, that works beautifully. Look at that. So this is the terminal and this is kappa. And it's just like, yeah, that's literally how it looks like. 2 bits kappa. Yeah. That's pretty potent. Pretty potent. So, okay. We want to do kappa pride, right? So let's put me in jail. Let's put me in jail for LGBT propaganda. Because I mean, I don't have any job. I'm running out of money anyway, so I mean, I'm joking. Everything's fine. Right, delegate kappa P PNG. There we go. And let's do color kappa P PNG. That worked great. Look at that. Savage banana soup. Thank you so much. Thank you. All right, that's pretty cool. Oh, you know what we need to test? Chat. We need to test KEGW. We must have KEGW in our terminal. We must have that KEGW PNG. Boom. Let's download that. Well, I mean, we have to do it like that. Yeah, there we go. So here's the KEGW. And what about the color? Why is this so funny? It's almost scuffed KEGW. Let me see the whole shit. I mean, we probably need to increase the size of this thing. Let's actually make it 128. That's a bit better. That's a bit better. JPEG compression be like, yeah, exactly. Oh boy, so it would be kind of cool to have even like this as a flag. So yeah, let's actually maybe provide this as a flag. So we can have resized width. Okay, but that also means we have to do some stuff. So this is resized width. This is initially null, right? And I need to start shifting the arguments and stuff. We can do something like this. I0. We're gonna start with like 1, right? We're gonna start with 1. So move the check for the file in here. Less than argc, right? So here we have maybe even flag or something like that. I just don't want to parse flags right now. You know what I mean? Kind of don't want to parse the flags. So I'll need to have the shift thingy. So let me find shift args. So I need to steal that stuff from somewhere here. Yeah, so that's what I have to do. So let's actually steal it from here. So shift args. Let's first of all assert that argc is greater than 0, right? And just save the program. Right, so this is going to be shift args, argc, argv, right? So here are all of the parameters, and while argc is greater than 0, we're going to be extracting the flag, right? So here's the flag, shift args, argc, argv, and let's do the switch. If strcmd flag is equal to, let's put w in here. If it's equal to w, we need to check the following thing. If argc is less or equal than 0, that means nothing was provided for that flag. fprintf std error, no value is provided for this thing, and we're gonna provide the flag. Okay, and we're gonna exit with 1. Otherwise, if it was provided, so this is gonna be the value. Shift args, argc, argv, and we basically assign this stuff to here. Like we convert it to integer and we assign it to resize width. So otherwise, if this is a known flag, we're gonna just put it into the file path, right? So we're gonna set it to file path flag. What's interesting is that if file path is already not null, we can say something like only a single file path is supported, though not necessarily. You know what? Not necessarily. One of the things we can do, essentially, for each file, we can literally print that file, right? Sounds like a cool idea. Actually, that is actually very cool. Right, so we can support several files and you can modify the sizes of those files on the fly. Man, that's so cool. This is such a cool idea. What the fuck? Wait a second. I really like that. So, let me put the initialization of the table at the top in here. So we initialize in the table. And then in here, we are doing the actual printing, resizing, and some other shit. Yo, man. The fuck? This is such a cool idea. Right, and this is gonna be something like this. So I can basically support several files in here. Right, and that should work. So, know what I mean? Know what I mean? Okay. So, but at the end of all of that stuff, we'll have to clean up these things. So otherwise it's gonna be leaking memory. So we'll have to free resized pixels, right? So we're freeing resized pixels, and also stbi free image or something. I don't remember how it works in image, right? So free something stbi free, let me see, what is it called? I can never remember. It's something like free data or what is it called? Who remembers? Image free, Jesus Christ. Okay, image free, and yeah, so you have to actually put the pixels in here, right? Essentially, we can provide several files, and it will work for several files as well. Okay, so that's cool. All right, it even compiled the first try. Okay, so we can provide the gbaited, right? And then I can provide also tsoding pog from the assets. There we go, and as you can see, it actually printed all of them, but then I can say, okay, for the tsoding pog, make it a little bit bigger. Well, I mean, that's too much bigger. Let's actually make it like 30, right? And I can modify those things independently, which is kind of cool, right? So I can say that, yeah. So basically, it interprets the arguments, right? So if it encounters set the width, it sets the current width, and then the next file is going to be with that width, and then the next file with that and that and that. So you basically like interpreting. So you're providing the program to interpret, which is rather convenient, I think. This is kind of cool. So then afterwards, we can just put another new line in here, right? So another new line. And now they are separated with new lines, and if you only care about like one specific image, you can put it in here. You can make it like as big as you want. So that's pretty cool, isn't it? Almost image magic. Can you image magic do that? Can you? What about wildcard? I mean, it's up to your shell, right? I'm pretty sure it's up to your shell. All right, so I think this tool by itself is already kind of useful, right? So, but one of the things we need to do, first of all, one of the things, is to fix the HSL table, right? So let's go ahead and fix an HSL table. So the way we can fix the HSL table is to actually generate it, right? So as we generate it, we can basically print this thing. So it's going to be D, like so. And then we just take this entire stuff, boom, and that's basically it. So here I'm gonna just exit with nothing, right? So because the only thing I want right now is to just generate. Well, I mean, those are the pointers. Let's get rid of the pointers. Alright, so this is the fixed table. And what we're gonna do in here, we're gonna literally copy paste it in here, right? So that's how we fix it, right? So I just literally regenerate it. Right, so who needs Jai with compile time evaluation if you can just run it and generate it and then copy paste it back? How about that? Isn't that cool? I think it's pretty cool. Right, so now here we don't need to initialize this thing. We don't need to initialize this thing. And we can take a look at some stuff in here. So let's take a look at the debated. Debated seems fine. So let's pick a reasonable size and let's take a look at some other things. So in POG, PNG, and what about the forests? About the olivets? Okay, so this looks good. Look at that. That's so cool. Let's make it smaller. I mean, I want to do olivets. There we go. Oh, how about 16? Or how about 8? So that's pretty cool. And yeah, like now we can publish this thing as the separate tool, as a separate project for people to play with. I think that's kind of cool, right? So how should we call this thing? How should we call this utility that takes a PNG image and converts it into the terminal, into the terminal colors and stuff like that? How did you fix the colors? The HSL values were wrong, but the RGB values were right. So what I did, I took RGB values and generated HSL from them, right? And then I just copy pasted generated stuff. Terminator is already overused name. I mean, like, so many projects already called the Terminator. Come on, 2 pixel for you. Term GL, this is not OpenGL, or even related to GL. PNG to term. What's interesting is that it is not only PNG. So it can also support JPEG as well. Maybe we can say image to term. Right, well, let's actually call it image to term. I think it's a pretty good name. Image to term. Alright. So thank you for all of your suggestions. They were rather inspiring. So we also need some dependencies, right? So we need to have STB image, and we also need STB resize. Right, image to term. There we go. So let's build sh bin sh. So if we do compilation, so we don't need that. Img to term. Okay, cool. So and now if I do something like that, cool. So we need something to test this stuff with. So let's actually go to assets, and I'm gonna just use the Sodium Pog, right? Let's do img to term, Sodium Pog. Well, I mean, yeah, this thing does not support that, but if I go to img to term and just do img to term Sodium Pog, PNG, it seems to be working. So maybe it would make sense to change the default value to something a bit bigger. Let's actually say it's going to be 32 or maybe 64. Let's remove that. So let's do build. It's too much. Let's go with 32. Also, I'm gonna trace everything because I like to see what commands shell executes usually. Right, so this is reasonable one. Yeah, I think this is reasonable. So another important thing, by the way, we need to assert, not really assert, but to put it to do. Check if the terminal supports 256 colors and stuff, right? And if it doesn't, and throw an error if it doesn't, right? Something like that. Also maybe similar 16 colors support? Question mark? Right? So that would be kind of cool. So, in terms of license, right, so in terms of license, it's under MIT, you can do whatever you want with it, and in terms of README, image to term, right, convert image to, okay, let's put it this way, print an image in the terminal using the terminal 256 colors, right? So, and we're also gonna do quick start. In the quick start, we just do console build sh and then image to term pog png. And furthermore, I think it would make sense to maybe provide some sort of a how to say that, screenshot, right? Some sort of a screenshot. Let's actually put 16 in here. So I think we need to make it more readable, right? I want it to be visible. I want it to be big, but also readable, right? So the bigger we make it, the less readable it is, right? Because it's pixelated. So let's do the following thing. I'm gonna copy paste the kappa, because kappa, the cool thing about kappa is that it looks good even pixelated. Right, so image to term kappa png, and I'm gonna just make it like 16 by 16, right? Something like that, or maybe even 8. Something like this. So, and this is a huge prompt. So let me quickly make it a little bit smaller. So I think prompt is PS1. Yeah, there we go. So, and this, boys and girls, could be a pretty good screenshot, right? We can try to turn this into a screenshot. Okay, so now I can actually copy paste that stuff into the project. Okay, this is not the right thing. Here's the screenshot. Okay, let's copy paste it. So thumbnail. Yeah, there we go. So we don't really need the kappa, right? We don't really need the kappa. And I'm gonna put this stuff in here. Maybe after that. Thumbnail png. Oh boy, right, so also git ignore image to term. Git init. So let's take a look. So this is needed, all of this stuff is needed. Ready, set, a go. Okay, and let's create a thingy-majingy. Okay, img to term. Print an print an image to terminal using 256, blah blah blah. Okay, good. Okay, good. Origin, boom, boom. And let's push that right into the repo. Yo, look at that! Give it a star, give it a like and subscribe, so you can now try to test it on your own machine and see if it works for you or not. Yo, isn't that cool? I think it's pretty cool. Useful. Okay, very pogue. I'm going to actually put that in the description as well for anyone who's watching live. Right, so there we go. Cool. So now we just need to use that in the actual demo renderer. That's what we need to do, right? So let's go ahead and do that. So initially we had this thing in Olive C. All right, so it's going to be build demo, and let's take a look. So I think it's going to be cup 3D terminal, right? So this is how our shader renderer looks like, right? Which doesn't really find the colors properly. We need to port this shader renderer to HSL one. So an HSL is like does a lot of like float stuff conversion, so it could become slower, but I'm gonna try to make it a little bit faster off screen already, right? So I'll see how I can just like, you know, get rid of the float stuff and yeah. Anyway, so Olive C, and I need to find the demo VC, right? So RGB 250, yeah. Okay, so this is what we have in here. Let's go. I want to have this thing. HSL. I'm gonna copy paste it in here. So this is HSL. Find ANSI by RGB. We don't need that. We need find ANSI by HSL. There we go. And this thing also needs the distance. Right, so that's quite important. Okay. Let's try to compile some of the things. So build C. I want to specifically compile. Let's actually start with the triangle example, right? So I'm going to remove these things. Okay, where is that? So this is going to be only the triangle, and within the demo we're going to be only building the term, right? So only building the term. So yeah, I'm building my project with C. I'm using C as a shell script. All right, so let's see. So what do we have in here? For the semicolon, anything else? Okay, so this is basically where we do all of that. We need to do by HSL, but then we need to convert all of these things to HSL, right? HSL. We need to do RGB to HSL, like so. H, S, and L, and I suppose we need to also copy paste the RGB to HSL, RGB to HSL. Let's just put it somewhere here. Let's put it here. Because why not? And then in here, we just do H, S, and L. Boom. What else do we have? F mode. Damn. So that means the terminal needs the math library, which it didn't need before, but we're linking with math anyway, so maybe that's gonna be fine. What else do we want? This one has to be a pointer. Anything else? So it's a non-standard thingy, which is understandable. Okay, that's very cool. Okay, so let's take a look at the triangle example and admire its beauty. Well, it didn't really work at all. Did it? Though it kind of worked, if you take a look at this stuff. So there's also bluish thingy that I'm really confused. What the hell is going on? Didn't recompile. You think I didn't recompile? It did recompile. But I recompiled, well, I mean, I recompiled the term example, right? So that's fine. Alright, so let's actually remove the build folder. In fact, let's rebuild everything. Let's just rebuild everything. So no build, what do we have in here? Let's just remove that, and let's just run everything. So that will rebuild everything. Rebuilding everything. That's, well, I mean, I'm kind of concerned. That's a bit sus. It's a bit sus that it didn't change. Okay. Okay, so yeah, all right. So, but what about squish term? Nothing changed. Damn. How did that happen? Oh boy. There we go. Distance to HSL. Find ANSI index by HSL. Okay. It's taken this long to recompile such a simple program. We're recompiling 24 programs. Okay, whatever. Compress pixels. I'm surprised why this does not work. Like, it literally didn't change. It literally didn't change. It's just so weird. Cup 3D. And yeah, and what about the teapot 3D terminal? Yeah. Well, I mean, it's different actually. I remember it being like completely different. And the most strange thing here is that it's also green background. It's not supposed to have a green background. You know what I mean? It's just not supposed to. Maybe there's also something with the alpha in here. So yeah, we also don't take into account alpha properly. So HSL. RGB to HSL. Let's actually do R. And that's red. G, B, A, green, blue, So, and let me go to image to here, this thing. So I'm gonna put it in here. RGB. Okay. I don't want to recompile everything, so let's actually recompile only that thing one more time. So assets, yeah. I suppose I'm gonna be. I don't need to rebuild tests, that for sure. Right, so let's only rebuild this stuff. The triangle. Well, I mean, it looks reasonable. That's the thing. Right, so you have a red corner, you have a green corner, and you have a blue corner. The only thing that I don't particularly understand is the background. Background is supposed to be grayish, but it's not gray. So that's what's weird. Well, that's what's weird about this entire stuff. Like, why is it so? Right. And also, okay, let's. What about squish? Man, I'm almost done. It's so frustrating. I'm almost done, and there's something stupid. There's always like one stupid bug And I just like don't know, man. God damn it. I just want to wrap it up. And yeah, so we know for a fact that this should have a reasonable color. Know that it has to have a reasonable color, but there's something and I don't know what. And it's just like, it's probably, I'm gonna go on a break and it's just gonna occur to me, but the stream is already over, right? So it's always like that. I hate it. Okay, it's something stupid. It's something very, very stupid. And it's just like, I don't know what. I probably missed something, but what did I miss? What did I miss? So here's the HSL. HSL is initialized properly, more or less, right? So we copy pasted it from there. RGB to HSL, so we get the RGB. Man, okay, so and then squish SDL. So yeah, everything seems to be alright. And the image, right, if we do color, assets, sudden pogue, everything's fine, right? So it knows how to properly put these colors, right? So the technique itself knows how to properly do that. It's just something. Okay, so this is the compressed pixels. So we see term char canvas. Are we using the right thing? 48.5. Yeah, that's what we're using here. That's what we're using here. And we just store the index in there. Alright, so that's the index, and we just store the index in there, so that should be fine. Probably need to make a small break. So yeah, let's make a small break. All right. So what's interesting is that here, what we do, we compress a chunk of pixels, right? And the way we compress the chunk of pixels is actually rather interesting. I've never even tested if it preserves the colors correctly. That's what's interesting. Right, I don't even know if it preserves the colors. Maybe it actually like screws them up really, really badly. So, and the reason why I never actually seen the colors is because we were rendering all of that without any colors. All right. So what's interesting is that maybe we could employ the resizing library, STB resizing library, but we have a custom way of resizing the image in here. So, and this is because we are essentially. How to say that, we're always like making the image smaller, so I thought that maybe I can like specifically for that just like make it just make a custom compression thing. So to test if we even compress everything correctly, I think it would make sense to maybe save the compressed image, right? Just save the compressed image and see if it like produces the like actually correct image. That will be interesting, I think. So let me try to do STBI or write image. Let's actually try to save that entire thing somewhere. Right, and STB image write, STB image write. Okay, so write PNG. Okay, so let's just write PNG. So the file is going to be something like debug PNG. Right, so the width is going to be, we see term scale down width. Right, so this is scaled down height. The amount of components is 4, and we should have the scaled down canvas, and I suppose the scaled down canvas is a character. Okay. So we are compressing the chunk, right? So we are compressing the chunk. Okay, this one is a little bit. We don't have a canvas for actual pixels because we're storing the indices. That's really bad. So that means I'll need to go ahead and allocate that thing as well. Ooh, that makes it complicated. Oh, I don't like that. Okay, so we have to do this like that. Right, so this is the debug canvas, right? And we are allocating this thing somewhere here, right? So this is the debug canvas, right? And we need to multiply that by debug here as well. I suppose that probably would make sense. Okay. Just by red. I remember this one, yeah. So essentially, if you couldn't allocate, just buy more RAM. Yeah, okay. So, yep. And essentially, I can do a similar thing here, right? So in the debug, I'm just saving the pixel, right? So here is the pixel. So that means here, when I'm saving the pixels, I can just like use the debug. There we go. Okay, and the stride is the size of uint32t, and this is the width, right? Multiplied by width. Okay, and after that I'm gonna just exit with the one. So we just taking the first frame and we're dumping it as a PNG image and just trying to see if it is like reasonable or not. You see what I mean? Okay, so it doesn't really work because we don't have STB image, right? So it's undefined reference. We probably need to include this entire thing. Okay, so let's just include STB image right h implementation, right? STB image right h implementation. Okay, so is it gonna work? So it seems to be compiling to some extent. Okay. So we were modifying the squish. Okay, so let's try to run the squish. Actually, the terminal version. Okay, so it's finished, and we have the debug PNG. Let's take a look at the debug PNG, and it's fine. The compressed colors are fine, so everything is totally fine. Believe it or not. So that's really weird. Okay, so, so. In assign char, so that's a good point, Alexor. Thank you so much. Yeah, it's storing the indices and assign char, so high indices become negative. Thank you so much. God damn it. There is a reason why you're VIP. There is a reason why you VIP. Thank you so much. Yes. Okay, so let's actually turn it into integers, maybe. Okay. Alright, so we probably need to go back. So exit 1, I'm gonna disable this thing and we need to recompile. Alright, there we go. Thank you so much. That's beautiful. That is actually, that looks so satisfying. Look at that. That's so cool. All right, so let's rebuild everything, literally. No build. No build.c. So, and also go through all of the examples and see how they work. It's pretty poog, yeah. It is in fact pretty pogue. To be fair, implementing all of that took way longer than I expected. But I think it's worth it, right? I think it's worth it. It's actually pretty cool. So I think it took like 3 hours of pure time, right? And also thinking outside of the stream, right? So no. So we started the whole idea actually in the previous stream. So you add 1 hour to that, so it's like 3 and 10. So yeah. Okay. All right. Let's actually start with the triangle, with the classical triangle. Look at that beautiful triangle. Wow. Yo. You can even see a little bit of like anti-aliasing at the edges of the circle. It's so cool. All right, so what's next? Dots 3D. Dots 3D. So this example. So since the resolution of this is kind of small, I'm not sure if it's gonna look good or not. So let's actually see. And it looks pretty shitty, but I mean, it's just like a low resolution. But you can see RGB and a boba there at the bottom. So this is supposed to be a boba. But yeah. Okay, so squish we already saw squish, right? So this is that. Triangle 3D, right? Triangle 3D, the 3D triangle. Okay, so this is like a rainbow triangle. The original thing looks like this, right? So this is the original thing. In the terminal, it looks like this, which is also reasonably good, right? Thing. Okay, so also the texture triangles, right? So this is basically like a 2 triangles rotated. So this is like a texture, but it's actually 2 triangles, and this demonstrates the ability to rotate the texture like however you want, right? So that's what you can do. Repo. Okay, so and now 3D texture, right? So can you even? You can't really see, but the second triangle is actually textured with studying pog. It's kind of difficult. If you squint a little bit from the far away, you can see that, but in the original SDL, it's actually more visible. Yeah, so maybe you should make like a cube out of that. We'll see. Okay, cup 3D. So we're getting into the territory of these kind of things, right? So this is a cup 3D. What about the terminal version? That looks good. That looks exactly how I want it to look. And the final boss of all of the demos is of course Teapot 3D, which in original looks like this. So this is original demo, right? There's like several thousand of triangles in here, right? So what about the terminal version? Well, we have to zoom out a little bit. So that looks reasonably well. In fact, that doesn't even look like it's in terminal. Man, that looks good. Yo, what the fuck? You can even see like a shade. Well, I mean, it slows down a little bit from time to time, but you can even see a little bit of like shading and stuff. The colors look kind of brighter. Well, I mean, we're kind of interpolating with whatever colors we have in the terminal. Yeah. That's so freaking cool, mate. That's so freaking cool. So I also, like, the only thing I need right now is just to clean it up a little bit and then publish it. Xterm haven't worked so hard since the Unix was born, yeah. Yes. Isn't that cool? Isn't that cool? I think it's pretty fucking cool. And that's all in terminal. Yes, it is all in terminal. So we are in terminal right now. As you can see, I'm trying to type, but I mean, it gets refreshed. Oh, yeah. So this is the terminal. And then you can run this thing one more time. Just zoom out a little bit, decrease the size. So it's twitching a little bit, but yeah, it's pretty cool. And this is sort of like ported from this SDL example, right? So it's literally, it's pretty much the same code, right? So whatever is running in terminal and whatever is running here is pretty much the same code. It's just like it's outputted to different like platforms, right? So we just like compile it differently. So, but the logic behind these demos is the same, right? The logic behind these things is the same. That's why it looks similar. So it's a little bit slower, but I mean, it's in terminal. All right, so I'm gonna clean it up off screen and then commit it to the repo for everyone to check out a little bit later. So the main, I think, outcome of today's stream is image to term, which is kind of a cool tool which allows you to take like image, like whatever image you have, assets, so in pole, right? For instance, like imagine that you have this image, and you can actually print it in a terminal, image to term. Assets, Sodium Pog PNG. There we go. So yeah, and if you want to use this tool, you know, on your machine, you can find it in here, right? All right, I guess that's it for today. Thanks everyone who's watching right now. I really appreciate that. Have a good one, and I see you next time. So yeah, love you all.